Hello everyone, my name is Harshit Jan and my other teammates are Ashutosh Shah and Abhishek Singh. We are Team Definite from IIT Kanpur MBA department and this is our summation for the Bits and Bytes case competition organized by IIM Bangalore. This is our Bits and Bytes project folder on the Ikigai platform and we have made several flows and we'll be discussing this in brief shortly. In this case, our task is to predict the salary by making a data app on the Ikigai platform based on the features such as job title, the location of the company, company name, headquarters, etc. We are given three types of dataset: training dataset, validation dataset, and test dataset. So our approach for the solution is we first load the all three dataset, do the data cleaning, uh, fit a ML model, test different ML models, select a particular ML model that works best for the dataset, then do the salary prediction, and finally evaluate the accuracy of the model. Here's our exploratory data analysis for the same. We first load the dataset on the Python notebook. As we can see, all the columns here are categorical variable. Only the rating variable is numerical. This is a huge challenge because we need to first convert all these categorical variable into some kind of encoding so that we can fit a ML model into it. So we'll start by data cleaning. We'll remove the negative values. For example, here we have removed the negative values from the rating column. Then we go to the job title column. We made a function called title cleaner. We applied this function on the job title column so that we are left with only four types of title called data engineer, director, data analyst, data scientist. And we have grouped all other titles into a column called other. Because this was not present very frequently in the dataset, so this won't affect the model much. Next, we do the similar kind of cleaning for title seniority that gives us senior, junior, and other. We have done similar type of cleaning for other categorical variables as well. And then we uh, yeah here we have made some kind of graphs that shows that which are the most prominent domains or like type of ownership, which are the most prominent industries in the dataset, the top 10 industries that appear most frequently, the top 20 sectors that appear most frequently. Then we have finally applied get dummies in order to encode the columns. So this is the final clean dataset that we have received. As you can see, all the categorical variables are now being encoded and changed into some kind of numerical coding. Finally, we apply the sklearn select k-boost mutual info regression in order to find out the columns which have the best mutual information gain. Then we select the top 36 out of these. Finally, we plot a heat map in order to find the correlation. And after final data cleaning, we are left with only 18 columns that are relevant for our prediction. These are the list of all 18 columns. Then we check the accuracy of different kind of ML models based on these selected columns. And we found out that random forest was working the best. We have checked the accuracy for linear regression, random forest, gradient boosting, and then voting regressor with random forest and gradient boosting. We select random forest for our project here for our case summation, and I'll be guiding you with the whole flow now. So we first clean the train data set. So this is the cleaning train data flow on the Ikigai platform. We load the training data set, pass it through a Python facet. This contains the whole EDA code that I showed you just now in the Python notebook. And then we store it into a data set called clean and label encoded train data set. We now pass this clean data set into a prediction model and train an ML model. We are using the random forest as we already discussed, random forest model with these hyperparameters. And finally, we export the result into a dataset called train data fed. Now, as we have already trained our ML model, we'll now use that model to predict the salary from the test dataset. So we clean the test dataset in a similar manner and then pass it through the ML model. Then we store the predicted result in a dataset called predicted test data. Finally, there is a evaluation facet provided by Ikigai that is used to predict the accuracy of our model. So we use the final predicted dataset called the predicted test data and then run this flow in order to obtain the final accuracy of the dataset. This is the final accuracy. We'll browse this dataset in order to check the accuracy. Okay. The RMSE score is pretty high here, but this is due to the fact that even the columns that we have selected that had the most mutual information gain had pretty low values, as you can see. So we believe that this data set does not have good information to make a prediction model. So this is the best model that's working for our data set. We can see the best information gain that we are getting is also just slightly above 0.04. So there's really less correlation between the target variable and our feature variables, and that is why we can see a high RMSE score here. Nevertheless, we have made a dashboard here. So this contains the whole flow. Then this is our raw data. This is how our clean data looks after encoding, and finally the predicted salary. So we have made a graph as well in order to show the test prediction salary. We can see most of the salary, the most frequent salary ranges from 50,000 to around 140,000, and then again the distribution reduces. Then we have summarized some KPIs here. So this graph here shows that like trained data average salary based on the industry. So these are the top 10 industry that has a maximum average salary, that offer the maximum average salary. Uh, we have used a similar pie chart here in order to describe the average salary based on the job title. These are the top five job titles, and these are their contribution. Like these are the average salaries of these five titles. Then by job location, we have again organized the average salary and grouped it based on the job location. So this was our whole dashboard and the flow. Thank you for watching.